Welcome back to my YouTube channel. So today we are looking at quadratics. So in my last two videos I posted a video on an alternative method of completing the square. Kutukanokapuwa quadratic equation, let's say for example x squared plus bx plus c, right? Let's say this is f of x, function of x. So Bwanzi express in the form a bracket x plus b squared plus c. There is a method that I taught, isiri the traditional method to complete the square, but that one totangata expand this thing, then you can attach expander chamo form yakafane each to compare my coefficients and constants on both the left hand side and the right hand side, right? So in the following video I then went on to show how to derive even the quadratic formula negative b plus or minus root of b squared minus 4ac, all that over 2a. We showed how that can be done. If you haven't watched those videos, you can go back and refer to those videos, right? But today I realized there is need for us to really ground our understanding when it comes to quadratics, to understand kuti chi chinombonzi a quadratic function. So let's just understand it from this point. Let's say f of x is equal to ax plus b. Function yatinayo upper e, it's known as a linear function because the highest power of x in this function is 1. So any function where the highest power of that function is 1, then it's called a linear function. If f of x is equal to ax squared plus bx plus c, the highest power is 2. And because the highest power is 2, then this is called a quadratic function. Right. Then if the function of x is equal to ax to the power 3 plus bx squared plus cx plus d, the highest power is 3. Therefore, it's known as a cubic function. Right. So, my quadratic functions are there, or maybe it becomes an equation when maybe we say, ax plus b equal to 0. This is for a linear function. And it can I so at this point, an equation, because an equation can actually be solved to get values of x. So in this case, it becomes x equal to negative b over a. And the same can be done. We can also solve for quadratic equations. So for quadratic equations, put ax squared plus bx plus c equal to 0. And in the last video, we derived equation, solve my quadratic equations, b squared minus 4ac, all that over 2a. So this method can solve any, this formula can solve any, besides factorization. If factorization fails, or not, you are wasting time in an exam situation trying to factorize, you can simply use the quadratic formula to even solve for the values of x. So graph ra x squared normally so it's just random. Y is equal to x squared plus bx plus c. This is the graph run y is equal to that function. This is how it looks like. This is the shape. So there is two things that I want you to take note here. Kana the function of x in a x squared plus bx plus c like this. Kana tichida kuona kuti shape yegraph redu rakaita sei, because ma quadratic function tine two types dzemashape. It's either graph redu rakaita a cup yakaita upside down kana rakaita cup proper cup. So for us to know which is which, we need to look at the coefficient of x squared. So if coefficient of x squared is equal to a positive number, can it a positive value for, in this case it's positive a, then that means the graph nenge really in this shape e cup each. Asikana coefficient if coefficient of x squared is equal to negative ringe rakadai, so graph racho. This is the graph. So already you can actually know the shape of the function of the graph by simply looking at the coefficient of x squared in the given function. You can actually tell. So originally, maybe just so you know, the graph of y equal to x squared rakangodai, y equal to x squared, this is the graph, right? Okay, so tiri pama quadratic function, there is something that I want us to look at. Takati sus quadratic equation yedu, x is equal to negative b plus or minus root of b squared minus 4ac, all that over 2a. There is something chatuda kutarisa chinonzi a discriminant. So discriminant yedu is equal to b squared minus 4ac. This thing chinowanika under the square root sign, this is what we call the discriminant. So discriminant yakanakira chinhu 1 inogona kutibatsira. It's actually a tool that we can use to arrive at a certain conclusion with regards to quadratic functions. So a discriminant inokwanisa kutibatsira kuunderstand anonzi nature of roots. So chii chinombonzi a root. A root is a point where the graph cannot the curve, the quadratic curve redu draw intersects the x-axis. For example, here to draw a graph ready, y equal to ax squared plus bx plus c. This is our x-axis, this is our y. So trikuti isusu chinonzi a root is a point where this graph y is equal to ax plus x squared plus bx blah 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 intersects the x-axis. So that would mean at this point, this is our first root, this is our second root. So quadratic functions, you can see antowanema roots. So discriminant yedu manje inotibatsira kuona kuti maroots edu akamira sei, the nature of the roots. So number 1, you need to know kuti kana isusu discriminant yedu b squared minus 4ac of a function kana iri equal to 0, zvinotipa anonzi ma-identical roots. Ngari 2 identical roots, which simply means it's one repeated root. And it ngori one root yadi yaitwa repeated. So for example, let's talk about this one. Ngatiti x inonzi graph ready. Toda kurowa graph y equal to x squared. Graph y equal to x squared ndataura kuti rinosviko richinotacha paorigin robva rakwira futi. So y equal to x squared function yakafanana nekuti x squared plus 0x plus 0. So toda discriminant yayo. So this is a, this is b, this is c. So for a tina 1, for b tina 0, c tina 0. So b squared is 0 squared until minus 4a, a in the 1, c ndiani, c in the 0. And it, so if you check panap discriminant yedu, and it, if you check discriminant yedu inobva yaita 0 if you solve for that. So it simply means tine 1 root iri kudzokorodzvoka 2. So that root panapa ndo paorigin painenge ichipfuura napo ndo nature of root yacho. Nature of root yeaya ndeyekuti it's just one repeated root kana kuti two identical roots. Naika. So I hope you understood that part. So maybe the practicality of it ichanyatsoonekwa patichazo attempt ma questions. So tikada kushandisa isusu maybe quadratic formula x equal to negative b plus or minus root of b squared minus 4ac over 2a is equal to negative b plus or minus root of tati isusu kana discriminant iri 0 over 2a. So discriminant ikaita 0 inobva ita root of 0. So ichi chinobva chaparara ichi panongosara 0. So that means x is equal to negative b plus 0 over 2a, or negative b minus 0 over 2a. X equal to negative b over 2a, or x equal to negative b over 2a. So if you use the quadratic formula, you can actually see why conclusion it is one repeated root, because it's just this root yafana e kana kuti two identical roots. Of course there are two identical roots. So number one, by nature of roots, when the discriminant is equal to 0, our roots are either two identical roots or one repeated root. Maybe zvaunongofarira kutsanangura iwewe ndo zvaunodi zvaunoshandisa. Right. Then number 2, kana b squared minus 4ac are greater than 0. Anything that's greater than 0, we know it's positive. And it go. So if b squared minus 4ac is greater than 0, is positive, tikatora value ye discriminant ye any quadratic function, tikatsvaga this discriminant, right, ikabuda iri positive value, one thing for sure we know, maroots iwayo they are two different kana kuti distinct roots. Don't mind. So what it means is, like I said, a root is a place, and it is a point where our curve and it intersects with the x-axis. So panapa R1, R2, so they are distinct, and it in the sense that anenge asina kufanana, the other root has a different value to the other root. Like, so we will look at it. We will look at it in a very interesting way. Takuita ma questions that tichabata pamberi apo. Then if our b squared minus 4ac is smaller than 0, that means canary smaller than 0, it's negative. Canary negative, there is no real roots. In other words, they are saying this curve never intersects. I intersect with our x-axis. So in other words, inenge riri suspended in air. Haritombotache kunoko. Haritombotache rinonge ringori tangirawo any point that is above the 0 mark on the y-axis, which is basically the x-axis, and ninenge chingotangira ipapo ichikwidza. There are no real roots. So this is everything about the nature of roots. So now, maybe just to summarize, let's have this number line. And then panapa ndo pana 0. So tikuti kana b squared minus 4ac yedu kana iri 0, it speaks to a repeated root, kana kuti two identical roots. And then we know kuti kubva panapa pana 0 tikatanga kumova tichienda ku left hand side tichiuya kuno tatoo ku negative section. And negative tati sus kana iri negative, kana b squared minus 4ac iri negative, kana that is less than 0. So zvinoreva ndezvekuti there is no real root. Then kana b squared minus 4ac iri greater than 0, that is to say it's positive, then inenge iri two distinct roots. So ngatiti wapuwa function of x sekuti y is equal to x squared plus 2x plus 1. Once tichagirawo maroots at this function, maroots at this function anowanikwa at y is equal to 0. So now the 0 is equal to x squared plus 2x plus 1. 0 is equal to, right? So panap netachi x plus 1, x plus 1. So that means tikauya nayo inoseta x equal to negative 1 ka 2. So if you check, iroriri is an example yateti taura anenge arima repeated repeated roots. Okay, so sorry, there we are saying x plus 1 twice. It's just a repeated root. So the nature of this root already it's two identical roots. Yekutanga kubva apa h2 kubva apa esaringobudisa negative 1. That is it. So that is the nature of roots for you. Then there is something else that we should talk about, which is called the turning point of a curve. Of a curve. So the turning point of a curve x1. In some cases, you may be asked to find the turning point, which is this point of a curve. Cannot even Ganarakadai, you may be asked to find the turning point of a somber coordinates of the turning point. Indeed. Right, so how do we find my coordinates of a turning point? So f of x is equal to ax squared plus bx plus c. So the coordinates of a turning point are found by the x coordinate is found by negative b over 2a. Then the y coordinate is found by c minus b squared over 4a. Right? ukatodai. So where do you get our A? Coefficient of x squared, our B coefficient of x, our C is our constant. So you are able to find the turning point of any quadratic function. So for example, let's say our function y is equal to x squared plus 3x plus 2. We want to find the roots of this first. 0 equal to x squared plus 3x plus 2. 0 is equal to x plus 1, x plus 2. Naiga. So if we solve, if we solve for this, we will find our x is -1, x equal to -2. This is our roots, and our roots are two distinct roots. Then the turning point would be, so our A equal to 1, our B equal to 3, our C equal to 2, right? So x is equal to -b, which is -3, over 2a to bracket 1. So it becomes -3 over 2. This is the x coordinate. The y coordinate, c, which is 2, minus b squared, 3 squared, and it over 4a, a is 1. So y equal to 2 minus 9 over 4. 2 minus 9 over 4. Let's type that out. Just a moment. So it's actually -1/4. So coordinates of the turning point, Edu, it's -3 over 2 minus 1 over 4. This is how we find the coordinates of the turning point. So in the case yekuti haukwanisi kana kufactorize like this, do not waste your time trying to figure things out. Just come and use the quadratic formula. Okay, so you're gonna have to take 1 or 2 questions that will work my exam style questions, so that we have a solid understanding. I think also I will have to post a video running my exam style questions on these things, the topic in my quadratics. Then we can proceed to the next topic. All right, so now we want to work this question here up. Express 2x squared plus 4 minus 4x plus 1 in that form. So let's work that out. So according to the method that I taught you, we start by expanding the given form. So after touch expander, we then equate it to the function irufana ku express kwa in this form, which is this function. So now let's equate my coefficients are x squared. Kunoku ku left hand side tina a, ku right hand side tina 2, so a equal to 2. Let's do that for my coefficients are x. 2ab ku left hand side, -4 ku right hand side. 2 times 2b, -4, 4b, -4b equal to -1. Then let's do it for the constants. So for the constants, ab squared plus c is equal to 1. A and 2. B squared -1 squared plus c equal to 1. So 2 plus c equal to 1, c equal to negative 1. So we express this function in this form. So our a is 2 bracket x plus negative 1 squared plus negative 1, which is our c. And it can so 2x squared minus 4x plus 1. So 2 bracket x minus 1 squared minus 1. It's identical to what we have on the right hand. So we express so. Then the next part, and hence find the coordinates of the minimum point. So isusu a on the curve, and so that isusu kana coefficient ya x squared and iri a positive number, graph redu nenge riri chikapu kudai, and so can find the minimum point. The minimum point of this graph is simply the turning point. So kana are positive coefficient ya x squared, vanogona kuti great turning point kana kuti minimum point. Asi kana coefficient ya x squared iri positive, which means the graph rakadai, unogona kuti great turning point kana kuti maximum point on the graph. So it's just the terminology yavanenge vachingotamba nayo, but in the end parikutaurwa chinhu 1. So pakutsvaga coordinates of the turning point neformula yandakupai yekushandisa, which is this. However, there is a simpler method yaunogona kushandisa. Since we unenge wane this converted form of the function, unogona kungotora iwewe this way coordinates of the turning point. For the x coordinate unoenda kunotora ichi chiri brackets obva wachiisa equal to 0. So x minus 1 equal to 0, x is equal to 1. So the x coordinate in the 1. Then for the y coordinate unongotora number inenge iriyo, that is chi plus c chia zvachingori. So chi plus c chia zvachingori, in this case it's negative 1. So y equal to negative 1. So my coordinates achona it's 1, negative 1. Do my coordinates are a, because that also kuti minimum point achona it's called a. Alright, so another question that we can take is this question here. In the quadratic equation you're given is equal to 0, k is a constant. Solve the equation in the case when k equal to 5. So to solve the equation in the event yekuti k equal to 5. So tiwane my values of x when k is equal to 5. Let's attack it and the solution. So k equal to 5. Pese pana k taku replace na 5. So k squared, kx squared plus 2 bracket k plus 1 x plus k minus 1 equal to 0. 5x squared plus 2 bracket 5 plus 1 x plus 5 minus 1 equal to 0. 5x squared plus 2 times 6, that's 12x, then pan up plus 4 equal to 0. So kana tichida kufactorize tisu, kana tichida kushandisa quadratic formula tisu. But to avoid wasting time, tichifactorize a wedu ndi 5, b wedu ndi 12, c wedu ndi 4. So x equal to negative b plus or minus root of the discriminant, which is b squared minus 4ac over 2a. X equal to negative b which is 12 plus or minus root of b squared, 12 squared, minus 4a d5, c d4, all that over 2 bracket 5. So x equal to negative 12 plus or minus root of, let's find that out by punching it on our calculator. So 12 squared minus 4 bracket 5 bracket 4, which is 64 here, all that over 10, negative 12 plus or minus root of 64, that's 8, all that over 10. Right, so minus 12 plus 8, minus 12 plus 8, that's negative 4. So x is equal to negative 4 over 10, or x is equal to minus 12 minus 8, which is minus 20, divided by 10, minus 2. So these are the results. So that will solve for x. Then secondly, find the set of values of k for which the equation is distinct real roots. So isusu tatikana ari distinct real roots, b squared minus 4ac must be greater than 0. Naiga. Yes, so b squared wedu, okay, chibi chedu the each coefficient of x, which is 2k plus 1 squared, because this is our b, so we put squared to it, b squared, minus 4a. What is our a? Our a is k. C, our c is k minus 1, all that greater than 0. So becomes 2 bracket k squared plus 2k plus 1 minus 4k bracket k minus 1, all that greater than 0. 2k squared plus 4k plus 2 minus 4k squared plus 4k, all greater than 0. So minus 2k squared, then plus 8k, plus 2 greater than 0. Naiga. So patasvika apa pakanaka zvokuti, nekuti isusu tiri kuda kutsvaga mubvunzo wedu uri kuti isusu titsvage set of values of k for which the equation has real distinct roots. So maybe if we move things to the other side, it becomes 0 greater than 2k squared minus 8k minus 2. Naiga. So we can try to factorize, or we can try to use the quadratic formula. Right, so if you use the quadratic formula, like highlighted on your right here, this is what you get for the values of x. So that means kana tichida kuwana ari factors tichigraduate kuuya panapa, this thing would be, tichigraduate kana kubva apa, whichever way it's okay, it becomes x plus root 80 over 4 multiplied by x minus root 80 sorry, I made a mistake. Let me just clear this out. All right, so I'm saying kana takuda kuona mafactors edu panapa tinoti x wedu anditika minus bracket 8 minus root 80 over 40. This is not x anyway, it's k. And then kuno also becomes k plus bracket 8 plus root 80, all that over 4, greater than 0. Less than 0. Less than 0. So now can tasvika apa, we can now solve for each. So k minus 8 minus root 80 over 40 is less than 0. So k is less than 8 minus root 80 over 4, not 40, sorry, over 4. Pardon my mistakes. Then this is this first set of value. It can be further simplified too. So if you simplify this, it becomes k is smaller than 2 minus root 5. So this is the first set of value. Then if you take the other one, which is k plus, if we simplify this thing, it simply gives us this, but it's okay. Let's just do this correct thing procedurally. Okay, so actually k plus 8 plus root 80 over 4 less than 0. Tika shift end of k is less than minus 8 minus root 80 over 4, which can be simplified as well. So k is less than minus 2 minus root 5. So this is the second set of values that we can get from this problem. So once again, thanking you for tuning in. Until next time, please don't forget to like, comment, share, and subscribe. Until next time.